Good afternoon, everyone. So I'm Sylvain Aubin with Siradel, and today I will be talking about the LoRa network planning challenges. And to do that, I will illustrate those challenges through several use cases, real use cases that we've been doing with several partners. First of all, a quick introduction about Siradel. So Siradel is you can say from my accent, is a French company. We are a subsidiary of ENGIE group. So ENGIE is a major French group and an energy and services provider. They are typically they are involved in the smart city market, but also the IoT, and especially in the LoRa. LoRa through Siradel, because we have been in the alliance for a few years now, and also through FlashNet. FlashNet is a company that is providing a smart lighting solution as well. So we've been created a few years ago in 1994. We are about 100 employees, and we are located in France, Canada, and China. We come from the connectivity, so we're providing solutions for network design. And we are also moving toward more generally the smart city planning, so looking at other verticals. So we are looking at connectivity, of course, but also smart city more generally, like attractivity of the cities. We are looking, of course, at energy and also mobility. And for all those different verticals, we have a common approach, and based on our capabilities. So we built the city in 3D when it's a city, but generally the territory. So basically, we're doing the digital twin of the city, for example. Then we aggregate in a platform, in a smart city platform, all the data coming from those different verticals. And for the different networks, we'll simulate and design the networks. And the last point as well, because we believe it's important, is to share and promote the data that we've been collecting, the conclusions, so that we can communicate to all the stakeholders of the project, especially when you are talking not to engineers, but more like citizens or city mayors, for example. So we believe that this last step is very important. But today, let's focus on connectivity. A brief word about where we come from. So we are experts in propagation and channel modeling. Propagation will be very important for network design, of course, because we want to have accurate simulation, coverage maps. And this is actually our core business. And our propagation model is also is accurate, but also can simulate the delay of the propagation. We've seen this morning the presentation from KPN, and we know that the delays on the propagation can have a major impact on the LoRa geolocation, for example, because it's based on TDOA. We have a brief word about another solution that we have, S5G Connect, which is dedicated for fixed wireless access and wireless backhaul. So fixed wireless access is basically an alternative to the fiber, so that you can bring a fixed broadband to your customers. Using, for example, the pre-5G or 5G, the millimeter wave. But the main focus of our presentation today will be the SIoT. So SIoT is a LoRa network planning tool. So you can simulate your LoRa network performance. And as I said before, we've been involved in the LoRa Alliance for 3 or 4 years now, and we've been working with the different partners like CNET in the US and Semtech as well. And we've been involved with Proximus when they started rolling out their national network in Belgium. So when we're talking about network planning, the first question is, what kind of data, map data, should I use? Because I'm going to need accurate data to simulate the propagation. So we have different products depending on the application, depending on the environment. So first of all, what we call 2D territories, this is dedicated for rural environment, where you will have, as we illustrate here for France, a description of the forest, the urban areas. So you will have a description of the terrain and the obstacles on the ground, the environment. Then we have something that we call 3D territories dedicated for smaller areas like a suburban environment, where here the advantage is that you have the real height of the obstacles, that it is important for the propagation, of course. And the last one, called 3D city, it's for urban environment. So here it's the example of Manhattan. The interest of this product is that you have a very accurate description of the building, so you have the footprints and the heights. That can be important to assess the indoor capabilities of your network. So here it's the video, if you can play it. So it's a project we've done, dimensioning a LoRa network in Portugal. So the purpose of this video is to assess the network cost, the deployment of the cost deployment of the network, basically mainly the capex. So and the objective is to assess the number of sites that needs to be deployed. It's not this slide, it's number 4. So believe me, we are able to assess the cost of the deployment depending on the network performance. So for example, defining a target like I want to reach 95% of coverage for a global country. What would be the cost of the network? So here it's a different use case. So here we have already a coverage, a macro layer deployed, so gateways deployed, like rooftop gateways. So it's in Grenoble, in France, urban environment. So we've done that with Semtech. What we are showing here is the coverage of the LoRa network. We have 2 different gateways here, so providing a global outdoor coverage of 100% SF12, but a poor indoor connectivity. So the legend here in blue is the SF7, and then we see all the different spreading factors. And here, what we want to evaluate is 2 different scenarios to bring a better indoor connectivity. And there's 2 different ways here we're going to see. It's either using macro gateways, so outdoor rooftop gateways, or Pico gateways, for example. And we will assess the capex. So mainly here, the capex we consider is the cost of the equipment, and the cost for outdoor gateways, the cost of the site. So here, the first scenario. So we're going to use only a macro gateway. We start from the 2 antenna gateways here, and we have the cost here of the network with only 2 macro gateways. And as a reminder, we cover the global area with SF12 outdoor only. Then we will densify the network. So now we have more gateways, and we see, here it's the different targets and the price. And we see here, so it's the range of price, because the price can depend on the equipment. And we see the price of the network to achieve the SF10 outdoor coverage. And then we will move to achieve SF12 indoor coverage, so 100%. And at the end, 100% of SF10 indoor. We see that to achieve this target, we need 42 macro gateways, and we have the price here. Now, let's say that I will keep the 2 macro gateways at the bedrock of the network, providing a global outdoor coverage. But now I will densify my network with Pico gateways, so it's the red dots here. And I will do exactly the same and see the impact on the cost. So with the target of SF10 outdoor, then SF12 indoor, and at the end, SF10 indoor as well. So we see that to achieve this target, we need the 2 macro from the beginning and more than 100 Pico gateways. But what is important is that we can actually compare the cost. of those two scenarios, and we see that to reach those to reach the indoor coverage, Pico gateways, densifying the network with Pico gateways can be a cost-effective choice. So it's a video, so I'm going to pass. It's about geolocation. So here, it's an operator in Mexico City with an existing network with 33 gateways. So here we have the map, the map for the spreading factor. So in blue, the spreading factor 7. And so with the 33 gateway, it offers global connectivity, outdoor connectivity with 70% of SF10. And we know, because in the simulation, we have some specific capabilities where we can evaluate the geolocation accuracy. When I talk about geolocation accuracy, here is the native LoRa geolocation, so with TDOA. And we were able to simulate that the average accuracy of the geolocation with these 33 gateways was around 500 meters. So it means that on this map, for example, we have, when it's blue here, it means that we can geolocate the device with accuracy, and then it goes to yellow and red, and we're losing accuracy. So here, if my final customer wants to address some specific geolocation use cases, and he needs a better accuracy than 500 meters, I can run different simulations. So this is our starting point with the 33 gateways, so with the 500-meter geolocation. And we can see that if we densify the network, so from 33 to 55, and at the end almost 150 gateways, we can get a much better accuracy, and at the end reach an accuracy of less than 180 meters. So we can simulate that. We can take this into account to dimension and design the network. So if you are targeting some specific geolocation use cases, you can take this into account. And once again, this is the TDOA LoRa geolocation targets. Something that is also interesting for densifying networks, because we've been talking about cost and mainly CapEx. So the cost of the network is not only the CapEx, and what can be important also is the battery life of your device. And we can also simulate the impact of the densification of the network on the battery life of the devices, because if you have more gateways, it's going to be easier for your device to reach the gateway. So this is also something that we can simulate. Then we have two examples. We've worked with TTN in Amsterdam and Berlin. And so TTN asked us to evaluate the coverage of their existing network in Amsterdam. So we got the information from them about the gateways. So in the black dots are the outdoor gateways, and the red dots are the indoor gateways. We have 34 indoor gateways with 18 outdoor gateways with different equipment. So sometimes, TTN, Carlink, LoRa, Raspberry, or Multitech. Sometimes we don't have the information, but this is what we got. And what we are doing here is that we want to simulate the global footprint, the global connectivity in the blue area, which is the administrative part of Amsterdam. And here we're displaying the coverage. Same legend in blue, SF7, and then the other color for all the other spreading factors until SF12. And we achieve global coverage on 50% in SF10. Two comments on these networks. On this network is that the gateways are mainly located in the city center, so we don't have any coverage issues here. But we can see in the west part that we don't have any connectivity. And also, all the gateways have an average height of 10 meters, which is pretty low, even if the Amsterdam buildings are pretty low. So that explains this kind of result, and only 50% of coverage in SF10. And we have, so the second example in Berlin. So exactly the same, we got the information from TTN with a little bit less gateways, 28 indoor and 17 outdoor. But we can see here that we have 70% of SF10 coverage, which is more than in Amsterdam. There are two reasons. We can see that the gateways are much better distributed on the area, and also that the height of the gateways is much higher. We had, for Amsterdam, it was 10-meter height, and here it's around 40 meters. I think those two examples illustrate pretty well the importance of network planning so that you can achieve an optimal network. So just as a conclusion, so, Siradel is an expert in connectivity and smart city planning, and we can help designing and dimensioning, optimizing your LoRa network thanks to our capabilities. So if you have any question, you can reach me anytime.
We have time for a question now. If you have a pressing question, Sylvain is still here. Or if you want to take a picture of Sylvain, his email address, you can do that now. Any questions? I just had one. I saw you, the median accuracy from 500 meter with 33 of gateways to 180 with 146 gateways. Is there, is this going somewhere? How accurate can you become? If you plant the whole place full with gateways, how accurate can you be?
I think it's better to ask the guy from KPN this morning, and he had some numbers, and he said on their network, for example, they managed to achieve for 50% of the devices an accuracy of 50 meters. This is what they are saying.
This is where we're eventually going as well, I think. Okay.
But it's a very hard question.
Exactly. Yeah. Okay, so that was it. A warm hand for Sylvain Aubin.
Thank you. Thank you.